This question here says, assuming the weight of this black 32 meters beam is negligible, what is the force that must be applied at this point A to make the beam lie directly on the horizontal axis? So how can this be solved? Well, let's see. Since we are assuming that the weight of the beam is negligible, that means the reason why this end is on the ground is because the weight of this 2.8 kilogram stuff is causing a moment at this point here, let's say P, by pushing the beam downward at this end. So for the beam to be balanced horizontally, we need a counter moment at this P, that is a moment about this point P with the same magnitude as the moment caused by this stuff here, but in the opposite direction. So let's write it out here. Counter moment equal to moment caused by 2.8 kilogram. And from the question, we are asked the magnitude of the force to be applied here to balance the beam horizontally. That means it is the one causing the counter moment. Now let's assume that we have the force now and the beam is lying on the horizontal axis already because of the force. So let this counter force equal to Fc. But what is the moment caused by this force at point P? We don't know. But formula for finding moment is force times perpendicular distance. Force is Fc. We can see since Fc is vertical and the beam is horizontal, that means this 8 meter is its perpendicular distance from this point P. That is perpendicular distance equal to 8 centimeters. Substituting here now, counter moment equal to Fc times 8 meters, which is 8 Fc meters. Now what is the moment caused by this 2.8 kg? 2.8 kg is the mass of the stuff. The force caused by this 2.8 kg mass is a weight of 2.8 kg times 9.81 meters per second squared, which is 27.468 kg meters per second squared. Kilogram meters per second squared is equivalent to 1 Newton. So force caused by 2.8 kg is 27.468 Newton. We are not given where exactly or at which point this force is acting. We just assume it's a uniformly distributed load, that is, the force is acting here at the center. Now what is the moment caused by this force at this point here? We don't know, but moment we know is force times perpendicular distance. Force is 27.468 Newton. Since the gravitational force is vertical and the beam is lying horizontally, that means the length of the beam from this point to this point is the perpendicular distance. So what is the length of the beam? We don't know. But recall here, the whole beam is 32 millimeters in length. So since from this point to this point is 8 meters and from here to here is 7.6 meters, that means from this point to this point is 32 meters minus 8 meters minus 7.6 meters, which is 16.4 meters. Now from this force to this point is half 7.6 meters because it's acting at the center of 7.6 meters. 1 over 2 times 7.6 meters is 3.8 meters. Now perpendicular distance is 3.8 meters plus 16.4 meters, which is 20.2 meters. Substituting here now, moment caused by 2.8 kg is 27.468 Newton times 20.2 meters, which is 554.8536 Newton meter. Now we have counter moment equal to 8 Fc meters and moment caused by 2.8 kilogram is 554.8536 Newton meter. Now substituting here now, 8 Fc meters equal to 554.8536 Newton meter. Dividing both sides by 8 meters, 8 Fc meters over 8 meters equal to 554.8536 Newton meters all over 8 meters. Here, 8 cancels 8 and m cancels m, while here also m cancels m and 554.8536 Newton over 8 is 69.3567. So Fc equal to 69.3567 Newton. That is 69.3567 Newton is the force that must be acted here against the weight of this 2.8 kilogram stuff to keep the beam lying horizontally, assuming the weight of the beam is neglected. Hi, good day viewers. You're welcome back. Today we are going to solve this interesting question here. The question says, this R here is a resultant of this force A and this force B here, which are both acting at this point Q here on this rectangular board. Find A the total moment caused by the two forces at point P and B, the value of force A and angle S. Before we start, we need to establish a free body diagram of the image. So how can we solve this? Let's start with the moment caused at point P. How can you find the moment caused by the two forces at point P? The formula for moment is force times perpendicular distance, and the resultant 160 Newton is the two forces combined together. So the force now is 160 Newton. But what is the perpendicular distance between the resultant and point P? We don't have it, though we can find it using this information here. But since the board is rectangular in shape and both its sides are directly on the x and y axis, we can use the Varignon theorem by adding the moment caused by the x component of resultant 160 Newton and the moment caused by the y component of 160 Newton with respect to the direction of rotation. So what is the moment caused by the x component? The moment caused by the x component is the x component times the vertical distance. The x component of a force is F cos theta, where F is the force and theta is the angle the force makes with the x-axis, or F sin Q if Q is the angle the force makes with the y-axis. But here we have the angle the resultant force makes with x-axis, which is 30 degrees, and the resultant equal to 160 Newton. So therefore its x component is 160 cos 30 degrees. So moment of x now equal to 160 cos 30 degrees times the vertical distance. Since the board is rectangular in shape and this side is 39 centimeters, this must also be 39 centimeters in length. So therefore, the vertical distance now is 39 centimeters. Now moment of x is 160 cos 30 degrees times 39, which is 5403.9985. So therefore, moment of x equal to 5403.9985 Newton centimeters. So what is the moment caused by the y component of the resultant? The moment caused by the y component is the y component times the horizontal distance. Now the y component of a force as well is either F sin u, where u is the angle the force makes with the x-axis, or F cos v, where v is the angle the force makes with the y-axis. We can use this here because the angle formed by the resultant force and x-axis is 30 degrees. So substituting now, y component equal to 160 sin 30 degrees. Coming back here now, moment of y equal to 160 sin 30 times horizontal distance. So what is the horizontal distance? The horizontal distance is already here to be 50 centimeters. So now, moment caused by y equal to 160 sin 30 degrees times 50 centimeters. 160 sin 30 times 50 is 4,000. So now moment of y equal to 4,000 Newton centimeters. And we have moment of x here to be 5403.9985 Newton per centimeters. Now the total moment caused by the two forces at point P is the summation of moment of x and moment of y. But before we do that, we have to consider the direction to which of x rotate the board and also the direction of y rotate the board. In rotation, we only have two directions, which are the clockwise direction and the anti-clockwise direction. So if we let the clockwise direction to be positive and the anti-clockwise to be the negative, taking moment of x now, the force here is the same as the force acting here, on the same line of force. And if the force is acting here, it is definitely going to rotate the board to this direction here, which is the clockwise direction. And therefore, the moment caused by the x component is positive. Coming back to the moment caused by the y component, on the same line of force, this force here is the same as the force acting here. And any force acting here will cause a rotation in this direction, which is the anticlockwise direction. And the anticlockwise direction we have here is negative, and hence moment of y has a negative sign. If we add them up now to have the total moment at P, moment caused at P equal to moment caused by x minus moment caused by y. M of x is 5403.9985 and M of y is 4000. So moment caused at P equal to 5403.9985 minus 4000, which equals to 1403.9985. So therefore, the total moment caused by force A and force B at point P is 1403.9985 Newton per centimeters. If we wish, we can convert the units Newton centimeters to Newton meters. C is centi, and centi is equivalent to 1 over 100. So moment now equal to 1403.9985 Newton meters times 1 over 100, which is 14.039985 Newton meters. Coming back to the second question here, which says find force A and angle S. Since we are done with finding the moment, we can take this part of the image out and concentrate on only the forces and the x and y axis. So now, how can we find force A and angle X? In resolution of forces, when we have the resultant of two or more forces, the x component of the resultant must always be equal to the summation of the x component of all the forces that make up the resultant. The same goes for the y component. The y component of the resultant of two or more forces is always equal to the summation of the y component of each of the forces. So now we can say f of x of the resultant equal to f of x of A plus f of x of B, and f of y of R equal to f of y of A plus f of y of B. We already noted that the x component of a force is f cos theta if theta is the angle the force makes with the x-axis, or f sine q, where q is the angle the force makes with the y-axis. So coming back to the resultant, 30 degrees is the angle the resultant makes with the x-axis. So the x component of the resultant is 160 cos 30 degrees. So we can substitute here. Coming here to force A, angle S is the angle force A makes with the y-axis, and hence the x component of force A is A sine S. Substitute it here. Now here, force B, this angle here, 23 degrees, is the angle force B makes with the y-axis, and hence the x component of force B is 100 sine 23 degrees. So if we substitute here now, 160 cos 30 degrees equal to A sine S plus 100 sine 23 degrees. Making A sine S the subject, we subtract 100 sine 23 degrees from both sides. Now A sine S equal to 160 cos 30 minus 100 sine 23. 160 cos 30 minus 100 sine 23 is 99.491. So A sine S now equal to 99.491. We have two unknown variables from the equation, and hence we can solve it using this equation alone. Now coming back to the y component of the force, the y component of a force is F sine u, where u is the angle the force makes with the x-axis, or F cos v, where v is the angle the force makes with the y-axis. 30 degrees is the angle the resultant makes with the x-axis, and hence the y component of the resultant is 160 sine 30. Substitute here. Angle S is the angle force A mixed with the y-axis, and hence the y component of force A is A cos S. Substitute it here. Coming to force B, 23 degrees is the angle the force makes with the y-axis. But if you look here, force B is in the negative y-axis, and hence the y component of force B is minus 100 cos 23. So now, sine 30 degree equal to A cos S plus open bracket minus 100 cos 23 degree, which is the same as A cos S minus 100 cos 23 degree. Making A cos S the subject, A cos S equal to 160 sine 30 degree minus open bracket minus 100 cos 23 degree. Here minus times minus is plus. So A cos X equal to 160 sine 30 degree plus 100 cos 23 degree, which is 172.0505. So A cos S now equal to 172.0505. And here we have A sin S equal to 99.491. In trigonometry, there is an identity that tan theta equal to sin theta over cos theta. So we can solve simultaneously by dividing this equation by this equation. Now A sin S over A cos S equal to 99.491 over 172.0505. Here A cancels A, and here 99.491 over 172.0505 equal to 0.5783. So sin S over cos S equal to 0.5783. From this identity here now, we can substitute that sin S over cos S equal to tan S. So now tan S equal to 0.5783. To find S now, we find the tan inverse of 0.5783. Now S equal to tan inverse of 0.5783, which equal to 30.04, approximately equal to 30 degrees. So this angle S now is 30 degrees. To find force A now, we can substitute S equal to 30 degrees into any of these two equations. So let's substitute it here. Now A sin 30 degrees equal to 99.491. To find A, we divide both sides by sin 30. So A sin 30 degrees over sin 30 degrees equal to 99.491 over sin 30 degrees, which equal to 198.982, approximately equal to 99. So force A now equal to 199 Newton, and we found angle S to be equal to 30 degrees. Hello, good day viewers. Today we are going to solve a question from mechanics. Okay, let's see what the question says. It says calculate the force at A and B, that is this support A here and this support B, if the cylindrical container with a radius of 1.5 centimeters hanging on the beam is filled with a liquid of 2000 kg per meters cube density. So how can you solve this? We can try equilibrium of forces by drawing a free body diagram of the beam here and all the forces acting on it. Nothing related to the mass of the beam, the container, the support and the rest are given, so we assume they are negligible. Let's draw a free body diagram of this beam here. What are the forces acting on it? Here, since we have a container with liquid in it, there must be a downward force at this point here, 3.5 centimeters away from point A. Let's say C. Here at this point A here and this point B, there must be reactional forces in the direction opposite to the applied force. So since the applied force is downward, the reactional force must be upward. The terminology of the equilibrium of forces is whenever all forces acting on a body are considered, both the acting forces and the reactional forces, the sum of the vertical forces must be equal to 0. Similarly, the summation of all the horizontal forces must be equal to 0. And also, summation of moment at all points must be equal to 0. There are no horizontal forces acting here, so this should be neglected. So coming back to the vertical forces, since summation of vertical forces must be equal to 0, in the vertical direction, we have the upward direction, which is in most cases considered positive, and the downward direction considered negative. So if we look here, we have 3 vertical forces, 2 upward, which are the positive, that is RA and RB, and then for C, which is downward, that is negative. So based on this here, we can sum them up and equate them to 0. Summing up now, RA plus RB minus FC equal to 0. Here, since the moment at all point equals to 0, let's take all the moment acting at this point A here, sum them up and equate them to 0. The moment caused by this RA here at this point A here is 0 because it's acting directly to the point. There is no perpendicular distance. Moment caused by this RB now, since moment is calculated by force times perpendicular distance, the force here is RB and perpendicular distance here is this one from here to here. That is 3.5 centimeters plus 6.5 centimeters, which is 10 centimeters. So MB equal to RB times 10 centimeters, which equal to 10 RB centimeters. Moment caused by this FC now will be negative because it will rotate the beam about a point in the clockwise direction, which is opposing the direction RB will rotate the beam about point A. So moment caused by force C is minus FC times 3.5 centimeters, which equal to minus 3.5 centimeters. Summing the two moments now and equating them to 0, 10 RB centimeters plus open bracket minus 3.5 FC centimeters equal to 0. Here plus minus is minus, so 10 RP centimeters minus 3.5 centimeters is equal to 0. We can add 3.5 centimeters to both sides of the equation. So 10 RB centimeters minus 3.5 FC centimeters plus 3.5 FC centimeters equal to 3.5 FC centimeters. Here, minus 3.5 FC centimeters plus 3.5 FC centimeters is 0. So 10 RB centimeters equal to 3.5 FC centimeters. Dividing both sides by centimeters now. Here centimeters cancel centimeters and here centimeters cancel centimeters. So 10 RB equal to 3.5 FC. Now what is force C? We don't know, but since the mass of the container and the support are negligible, that means we are going to only deal with the liquid. So what is the force caused by the liquid? The force caused by the liquid is actually its weight, and weight is calculated by mass times gravity. Gravity has an approximate value of 9.81 meters per second squared. So weight equal to mass times 9.81 meters per second squared. But what is the mass? We don't know. Though here we are given the density of the liquid to be 2000 kg per meters cube. Formula for finding density of liquid is mass over volume. Equating it to 2000 kg per meters cube now, mass over volume equal to 2000 kg per meters cube. Making m the subject of the formula, we multiply both sides by v. So m over v times v equal to 2000 kg per meters cube times v. Here, v cancels v. So what is the volume of the liquid? Since liquid controls the shape of its container, and here it says that the container is filled up, that means the volume of the container must be the volume of the liquid. So what is the volume of the container? The formula for finding the volume of a cylinder is pi r squared h. Pi is 22 over 7. R is radius, and we have the radius of the cylinder here to be 1.5 centimeters. And we can see that height here is 5 centimeters. But since this is in meters cube, we have to convert this to meters first. 1.5 centimeters to meters is 1.5 over 100 meters, which is 0.015 meters. 5 centimeters to meters is 5 over 100 meters, which is 0.05 meters. Substituting here now, v equal to 22 over 7 times 0.015 meters all squared times 0.05 meters, which equal to 3.5357 times 10 power minus 5 meters cube, which approximately equal to 3.54 times 10 power minus 5. So v equal to 3.54 times 10 power minus 5 meters cube. Substituting here now, Mass equal to 2000 kg per meters cube times 3.54 times 10 power minus 5 meters cube. 2000 times 3.54 times 10 power minus 5 is 0.0708. So mass equal to 0.0708 kilogram meters cube per meters cube. Here, meters cube cancels meters cube. So mass equal to 0.0708 kilogram. If we come here and substitute it, weight equal to 0.0708 kilogram times 9.81 meters per second squared. 0.0708 kilogram times 9.81 meters per second squared is 0.694548 kilogram meters per second squared, which approximately equal to 0.7 kilogram meters per second squared. So weight equal to 0.7 kilogram meters per second squared. We know the unit kilogram meters per second squared is equivalent to 1 Newton. So weight equal to 0.7 Newton. Recall, weight here is equal to force C. So force C equal to 0.7 Newton. Substituting here now to this our equation, 10 RB equal to 3.5 times 0.7 Newton. 3.5 times 0.7 Newton is 2.45 Newton. So 10 RB equal to 2.45 Newton. Dividing both sides by 10 to make RB the subject, 10 RB over 10 equal to 2.45 Newton over 10. Here 10 cancels 10, and here 2.45 over 10 is 0.245 Newton. Now RB equal to 0.245 Newton. Coming back to this our great first equation, if you substitute FC equal to 0.7 Newton and RB equal to 0.245 Newton, RA plus 0.245 Newton minus 0.7 Newton equal to 0. 0.245 Newton minus 0.7 Newton is minus 0.455 Newton. So RA minus 0.455 Newton equal to 0. To make RA the subject of the formula, we add 0.455 to both sides. Now RA equal to 0.455 Newton. So we found the forces acting at A and B to be reactional forces of 0.45 Newton and 0.245 Newton. Is it possible to find the magnitude of this force P here, even though the size of this angle here is unknown? Well, let's check it out. We can see at this point here, 4 concurrent forces of different magnitude and direction are acting on it. And we have the resultant here, which is 1 kilonewton. If we look here, this is the y-axis. So since the y-axis is always perpendicular to the x-axis, that means this line here is the x-axis. Since here it is at right angle with the y-axis, that is, the resultant force is acting directly on the x-axis. Though, we should not forget that since this is the y-axis, there is a negative y-axis, while this is also the negative axis because here this is the positive x-axis. So how can we solve for force P and theta? In equilibrium of forces, when all the forces at a point are represented, including the resultant or reactional force, summation of f of x equal to 0 and summation of f of y is 0. So what is the summation of f of x? Summation of f of x is all the forces acting on the x-axis. Okay, here we have the resultant 1 kilonewton, which is acting directly on the x-axis. Since it is acting directly on the x-axis, that means f of x for resultant is 1 kilonewton. Here, for 400 Newton, what is the f of x for 400 Newton? The formula for finding the x component is f cos A, where A is the angle the force makes with the x-axis, or f sin B, where B is the angle the force makes with the y-axis. So here, f is 400 Newton, and if you look, the force bisects this right angle here. 90 over 2 is 45 degrees. So A, which is the angle inclined with the x-axis, is 45 degrees. Substituting here now, f of x for 400 Newton is 400 cos 45 degrees, which if we press your calculator equal to 282.84. So f of x equal to 282.84 Newton. Here, f of x for P, since P is in the negative x-axis, f equal to minus P. And here, theta is the angle it makes with the y-axis, that is B equal to theta. Substituting here now, f of x for P is equal to minus P sin theta. Here, for 1000 Newton, since it is in the negative x-axis as well, F equal to minus 100 Newton, and here 70 degree is the angle it makes with the y-axis. So B equal to 70 degree. Substituting here now, f of x for 1000 Newton is equal to minus 1000 sine 70 degree, which if we press the calculator equal to minus 939.69. So f of x for 1000 Newton equal to minus 939.69. And here, for 0.4 kilonewton, you can see is acting directly on the y-axis. That is, it does not act along the x-axis at all. So f of x for 0.4 kilonewton is 0. Now summation of f of x is the summation of all these forces here. So adding up now, summation of f of x is 1 kilonewton plus 282.84 newton minus p sine theta minus 939.69 newton. Converting 1 kilonewton to newton is 1000 newton. 1000 newton plus 282.84 newton minus 939.69 newton is 343.15 newton. So summation of f of x is equal to 343.15 newton minus p sine theta. But here, we acknowledge that summation of f of x equal to 0. Substituting here now, 0 equal to 343.15 newton minus p sine theta. To bring back p sine theta to this side here, we add p sine theta to both sides now. 0.p sine theta equal to 343.15 newton minus p sine theta plus p sine theta. Minus p sine theta plus p sine theta is 0. So p sine theta equal to 343.15 newton. Now coming back to this, summation of f of y equal to 0. What is summation of f of y? It is the summation of all the forces acting along the y-axis. Here, resultant 1 kilonewton we can see is acting directly on the x-axis. That means it does not act on the y-axis at all. So f of y for 1 kilonewton is 0. Here, 400 newton, the f of y for a force is F cos B or F sine A. So for 400 newton, F equal to 400 newton, and here the angle it makes with the y-axis is 45 degree, so B equal to 45 degree. Substituting here now, F of y equal to 400 cos 45 degree, which if you press your calculator equal to 282.84 newton. So F of y for 400 newton is 282.84 newton. Here for this force P here, F equal to P, and the angle it makes with the y-axis is theta. So substituting now, F of y for P equal to P cos theta. Here for this force 1000 newton, if you look, it is acting on the negative y-axis. So F equal to minus 1000 newton, and here the angle it makes with the y-axis is 70 degree. So B equal to 70 degree. Now substituting here, F of y for 1000 newton equal to minus 1000 cos 70 degree, which if you press your calculator equal to minus 342.02. So F of y for 1000 newton equal to minus 342.02 newton. And here we can see this 0.4 kilonewton is acted directly on the negative y-axis. So F of y for 0.4 kilonewton is minus 0.4 kilonewton. Minus 0.4 kilonewton if you convert to newton is minus 400 newton. So F of y for 0.4 kilonewton is equal to minus 400 newton. Now summation of F of y is the sum of these forces here. So summing up now, summation of F of y equal to 282.84 newton plus P cos theta minus 342.02 newton minus 400 newton. 282.84 newton minus 342.02 newton minus 400, if you press the calculator, is minus 459.18 newton. So summation of F of y equal to P cos theta minus 459.18 newton. But here we have summation of F of y equal to 0. So that means summation of F of y equal to P cos theta minus 459.18 newton equal to 0. Here we can bring back 459.18 to this side by adding it to both sides. Now P cos theta equal to 459.18 newton. Now we have two equations, P sin theta equal to 343.15 newton and P cos theta equal to 459.18 newton. So how can we solve for P and theta now? We can solve the two equations simultaneously by dividing this equation here by the second one here. Now dividing, we have P sine theta over P cos theta equal to 343.15 Newton over 459.18 Newton. Here, this P cancels this P here, and here 343.15 Newton over 459.18 Newton is 0.7473. So sine theta over cos theta equal to 0.7473. Now from trigonometry, we know that tan theta equal to sine theta over cos theta. So if we replace this sine theta over cos theta with tan theta, we're going to have tan theta equal to 0.7473. To find theta, we'll find the tan inverse of 0.7473. So theta equal to tan inverse of 0.7473, which if you press your calculator equal to 36.77. So theta equal to 36.77 degree. Substituting into any of these two equations here, let's substitute here now. P sin 36.77 equal to 343.15 Newton. Sin 36.77 is 0.5986. Dividing both sides by 0.5986, we have P times 0.5986 over 0.5986 equal to 343.15 Newton over 0.5986. Here, 0.5986 cancels 0.5986, and here 343.15 Newton over 0.5986 equal to 573.25 Newton. So P equal to 573.25 Newton. We found the magnitude of speed to be 573.25 Newton, and theta, the angle it makes with the y-axis, is 36.77 degree approximately. Thank you for watching. Please subscribe, like and share, and also comment.